Thank you. Can you guys hear me okay? Is that better? Okay. So as we understand language, we predict or anticipate upcoming linguistic input. Prediction is widely viewed as a mechanism which supports fluent language comprehension, and we make predictions at many different levels of language. As speech unfolds, adults also take into consideration background or world knowledge that's shared between ourselves, the listener, and the speaker, as well as the real-world context in which an utterance is produced to help constrain the range of potential predictive inferences that we make. So to do so, we leverage a situation model, or an incrementally created conceptual representation of the events under discussion that can include spatial, temporal, and causal elements. So during language comprehension, listeners integrate incoming linguistic information with the current state of the model, a message-level representation that allows us to generate live pragmatic inferences about who or what will be mentioned next. Newland and colleagues in 2007 reported particularly clear evidence of adults using the situation model to generate predictive inferences. So they found that when adults encountered definite expressions, such as the nephew, in discourse contexts where there were two nephews introduced, they found the phrase ambiguous. For those of us familiar with this area, they were looking at the NREF ERP component. However, in a discourse context in which two nephews were introduced, but one left the scene prior to the critical sentence, participants found the nephew unambiguous. The linguistic prominence of each of these nephews in the story was carefully controlled. So this inference was generated as a natural consequence of creating a structured event representation that included the bindings between predicates and their arguments, as well as the causal relations within the event. So there's a lot of work about adult situation model use, but there's relatively little known about children's use of situation models, especially as it relates to predictive language comprehension. So in this current project, we're trying to chip away at this big question: to what extent and at what ages do children leverage the situation model to support predictive language processing? We know that children predict. So young children, 2 to 3-year-olds, generate predictions during in-the-moment comprehension based on linguistic information. For example, 2-year-olds use the semantic constraints of a verb to predict an upcoming argument. That is, when they hear "the boy will eat," they begin looking at an edible object, a cake, before hearing the noun. There's also clear evidence from offline tasks that young children construct situation models as they listen. For instance, 3-year-olds more accurately recalled story sentences if the main verb in the sentence was consistent with the story protagonist's perspective, showing that they're tracking spatial information as they listen. And in another story retelling paradigm, 3-year-olds changed the ordering of narrative events so the causal relations in the event better matched their background knowledge. For instance, they took sentences like "the daddy was late for work and so the bus broke down," and repeated them as "the bus broke down and so the daddy was late for work." So this tells us they're generating these inferences, these representations. It doesn't tell us whether they can use them for quick online predictions. Recently, work from myself and Cindy Fisher found that 4- and 5-year-olds can make quick predictions from the situation model. So in this visual world narrative comprehension task, which was designed to be really similar to that two nephews experiment I just told you about, we introduced children to two ambiguous referents: the bunny with the necklace and the bunny with the crown. In stories where two bunnies were introduced and neither left the scene, hearing "she asked the bunny with the" was found to be ambiguous. So children weren't able to look to the target animal until they heard the modifier. However, in discourse contexts where one bunny did go home prior to this critical sentence, before hearing the modifier, children looked to the target referent, showing it was unambiguous in this context. So it demonstrates clear evidence that these big kids, 4- and 5-year-olds, are capable of performing causal reasoning over their representation to generate new pragmatic inferences as they're listening. This finding really made us wonder whether a situation model would be involved even earlier in comprehension. So we know that causal reasoning over event knowledge is involved in non-linguistic domains from very early ages. For example, in a task developed by Sassana Arlati and colleagues, while watching silent events of object interactions, 12-month-olds successfully generated an inference about the contents of a container by tracking which of two objects was excluded from the container. So I don't have time for a complete description of this task here, but what's important to note is in that last image, there's a visual ambiguity because these two objects are designed to be the same, look the same, if only a little bit is sticking out from that container. And so the only way to know which object is in that container is by tracking which object had just come out from behind the screen, here the snake. So in both this and our prior narrative comprehension task, children incrementally built a representation of an event and reasoned over that representation to make quick predictive inferences. However, another not mutually exclusive possibility is that the ability to generate these predictive inferences arises from the ability to construct more complex language via maturing language skill. In fact, in work studying second language acquisition, many studies have observed a positive association between L2 proficiency and prediction. So in this study, we specifically asked whether 3-year-old children could use the situation model to generate quick predictions to constrain the interpretation of a referentially ambiguous noun. And within this data set, we also explored whether this was associated with individual variation in language skill. So to answer these questions, we employed an eye-tracked narrative comprehension task based on with stories modeled after the prior older kid study from Yuile and Fisher. So I'm going to show you data from 115 native English-speaking 36-month-old children. The age range for this study is 36.0 to 36.99 months. They've just turned 3 years old. And this is 2 years younger than the average age of the prior experiment, which from a developmental perspective is a big difference. Children listened to 24 stories, and we blocked the presentation order of story condition. We manipulate condition within subjects. So we have 3 conditions: an ambiguous condition, a 1-referent unambiguous condition, and a 2-referent unambiguous condition. So I'm going to help you understand what those condition labels mean by walking you through one of our stories. So every story starts with an introduction. Maisie was at the beach with her friends, the frog with the hat, and the frog with the scarf. Then what comes next varies by story condition, and we vary the conditions along 2 dimensions. So either we introduce 2 same species animals or 2 different species, and we manipulate whether one of the animals goes home. So in ambiguous stories, we introduce 2 same species reference and neither goes home. The frog with the hat was walking, the frog with the scarf was walking too. In 1-referent unambiguous stories, we introduce 2 different species of animals and one goes home. The frog with the hat was walking, the butterfly with the scarf went home. Finally, in 2-referent unambiguous stories, we introduce 2 same species reference, but one goes home. The frog with the hat was walking, the frog with the scarf went home. All stories end with our critical sentence. Maisie asked the frog with the hat to play with her. And the ambiguity of the noun phrase in this critical sentence varies by story condition, at least up until you get that modifier. As children listened, they looked at images of the story participants and the setting, like this. In addition to the primary experimental task, we also collected measures of language skill. Specifically, we collected a measure of children's receptive vocabulary, the Peabody Picture Vocabulary Test, or PPVT. And we also measured children's morphosyntactic skill using the Structured Photographic Expressive Language Test, or I'm going to call this the SPELT. So this is a production measure. It focuses on children's use of function words, morphology, and syntax. We reasoned that including this would be good because there are theories of prediction that suggest it engages the production system, and this is a production task, as well as because it is used often in the literature on developmental language disorder. So it seems like it might be a particularly good assessment of children's developing language skill. So we were interested in where children would be looking at either of the 2 referents as they heard the noun phrase, the ambiguous portion of the noun phrase during that final story sentence. So as they're hearing the frog with the before they get the modifier, because we thought it would vary based on story condition. In the ambiguous condition, this phrase is ambiguous. 2 frogs were introduced, no one's gone home, so you have to wait for the modifier to know where to look. In the 1-referent condition, the frog is unambiguous because only 1 frog has been introduced. So during this region, you should look at the frog as opposed to the butterfly. Finally, in the 2-referent condition, the frog is unambiguous because while 2 frogs have been introduced, children can use the semantic constraints of the prior discourse to figure out who Maisie is going to ask. Only 1 frog is left in the scene. So we also expected anticipatory looks in this window. Thinking about our measures of language skill, we actually pre-registered that we didn't expect an effect of receptive vocabulary on anticipatory fixations because we measured receptive vocabulary with the older kids and didn't find an association, although there are a lot of reasons why it wouldn't be surprising to find an association here. And we did expect a positive association between our morphosyntactic measure and looking at the target in this window. We reasoned that more advanced scores on this measure would index more advanced skill at integrating information across discourse sentences. So this is the time course of reference resolution in our final story sentence. On the y-axis, I'm plotting a measure we call log gaze. This is a log-adjusted target advantage score. The formula for it's in the corner of the slide, but what's important to know is that values above 0 represent more looks to the target relative to the distractor. And the x-axis is time in milliseconds from the onset of the sentence, and I've marked the average onset and offset of this ambiguous noun region for you. So during this section, they're hearing Maisie asked. During this section, they're hearing the frog to play with, the frog with the, and this one they're hearing hat to play with her. So we averaged over fixations in this ambiguous noun window for our analysis. There's a couple of things I should note about this noun window. First, that these were naturally recorded speech with words varying in length in this window, like cat versus alligator. So this window was defined on a story-by-story basis. And we offset this window by 500 milliseconds to account for the time it takes to plan and execute an eye movement. So when we averaged across fixations and ran a regression model, we found a few interesting things. So now I've changed the figure on you. This is average log gaze within the ambiguous window. So first, we compared the two referent to the ambiguous trials, because if 3-year-olds exploit the constraints of the situation model, then in 2 referent trials, they should identify the target in this window before they're getting the modifier. And this is, in fact, what they're doing. They're making this pragmatic inference. We also looked at the comparison between the 1 referent and 2 referent unambiguous trials, because if 3-year-olds find stories with 2 potential referents ambiguous, even after 1 referent leaves the scene, they should look more to the target animal in the 1 referent than the 2 referent trials, and I don't have to put this up there. You know that this is significant. So this is an effective semantic inference, is what I'm calling this. We also found a main effect of our SPELT measure, our morphosyntactic measure, showing that children with more mature morphosyntax had more fixations to the targets generally. And finally, this last point, we found interactions between PPVT, receptive vocabulary, and both of our condition comparisons, which indicated that children with larger receptive vocabulary showed larger effects within each comparison. I wanted to further explore the effect of language skill within noun window, and so what I did is I categorized our participants as either having an early language delay or having typical development based on criteria that's been used in the literature on developmental language disorder, utilizing the SPELT measure. We chose this because of its prevalence in the DLD literature, but I'm not using the label DLD here because children at this age, at 3 years old, cannot be consistently diagnosed with DLD, and many of these kids that you see captured here are actually going to catch up to typically developing peers. So this is our averages of log gaze within the ambiguous noun window for each language group and story condition. And here what I wanted to know was just whether looking within each group, each condition for each group differed from chance level. And chance level would be 0. So what I found was that in the typically developing children, they looked more than chance at the targets in both 1 referent and 2 referent unambiguous trials. But for the children categorized as having a language delay, it was only in the 1 referent trial that they showed the target advantage. So what can we conclude from this experiment? Well, we have clear evidence that 3-year-olds leverage the causal information in the situation model to generate live predictive inferences about who or what is going to be mentioned next. And it seems that this ability is varying by early language skill. You might have noticed that our pragmatic effect here was small and be wondering why this is. So I'll highlight 3 possibilities. First, this might be a consequence of our task design. So in particular, the fact that we didn't include a task that might have helped motivate the predictions in children. So in work with adults, researchers have found that participants are more likely to predict when the task instructions tell them to do so. And in our prior experiment with 4 and 5-year-olds, we used a task that I think might have helped motivate the predictions. So specifically, the older kids in the prior experiment answered memory questions after every single story, and then worked collaboratively with the experimenter to act out the story events by moving the images. So it could be that this helped to motivate the predictions in this older age group, while the 3-year-olds were just asked to sit and listen. So in this way, the current task is a little bit more like naturalistic language comprehension, and we still find them making the prediction. It's also possible that this is just related to development in processing speed. So in our task, children really need to quickly integrate the incoming linguistic input. We know adult predictive language processing can be affected by individual differences in processing speed. So thinking about developmental populations, in prior work looking at pronoun comprehension, so specifically the development of a first mention bias, and here I'm bringing this up because this is 3-year-olds using semantic content from, or using, not semantic, but using something from the prior discourse sentences to predict. 3-year-old success relies on being given a long window for prediction. So in these Song and Fisher studies, something like 4 seconds. And prior work also shows us that children become faster at using this first mention pronoun bias during the preschool years. So maybe the 3-year-olds in this sample were slower to bring the situation model to bear on their predictions about reference. Finally, it's possible that this is due to our chosen method. So I think that the visual world paradigm overestimates referential ambiguity. So if you look at the adult ERP experiment that these studies are modeled after, the one with the 2 nephews, what you find is that the 1 referent and 2 referent conditions actually pattern together. That is, looking at the data in this plot, 1 referent and 2 referent lines appear to be at the same level, suggesting that the participants in that experiment didn't detect any referential ambiguity in the 2 referent trials. So why is it that the 2 referent trials seem to be somewhat ambiguous in my visual world experiment? Well, maybe because the presence of a second frog on the screen creates a visual distraction. So in fact, recent work that directly compares eye movements and ERPs in the same task, this one was a referential communication game, shows that the visual display creates an attentional distraction even when ERPs for the same task don't suggest there's referential ambiguity. Okay, so finally, I want to spend a minute considering my findings with regard to children with language delay. So it's relatively well known that children with DLD show differences from typically developing peers in their ability to generate event-based predictions. So our post hoc findings are not super surprising. But we're not sure why these group differences emerge, and these differences could arise for many reasons, some that are related to things we've already been thinking about. For instance, children with DLD have less robust lexical semantic knowledge, which includes knowledge about verbs and their arguments. So in our experiment, the prediction relies on the main verb in the critical sentence, ask, which presupposes that a person is there to ask. So children with less robust knowledge of verbs and their argument structures might not be able to use this information or use it quickly enough to generate the prediction. We also know from prior work that there are group differences in processing speed between these 2 populations. So reaction times in children with DLD are generally slower than TD peers across cognitive domains. And finally, researchers have observed group differences between children with DLD and TD with regard to their working memory skill, which would be important for constructing and incrementally updating the situation model. Or maybe there's also a lower level explanation here, which I'd already brought up earlier in the talk, which is that this is a production measure. Some prominent theories of prediction suggest that it engages the production system. Perhaps children who are better at producing language are better at predicting. Okay, so with that, I'll just say thank you and answer questions.
Hi, Jessie Snedeker. I think I'll start with this question.
Okay.
So one thing I found myself wondering towards the end, right, is how to think about the processing of the incoming noun and the role that it might be playing here. And when you refer to as pragmatic inference, you refer to as you interpret as the inference that because the other entity is not on the scene, you can only ask the question of the entity on the scene. And that seems plausible. But I also wonder about something else, right? Which is that to disappear the other guy, right? You had to mention them in the immediately previous sentence. And so I'm wondering if we're looking at some kind of repeated noun penalty, right? Wouldn't it be more natural to say, the pig's a girl, right? Or Maisie's a girl.
Maisie's a mouse.
Well, Maisie's a girl mouse.
Yeah.
Maisie's a girl mouse, right? So, so I think there's no interference if we say Maisie asked him.
So I think, so maybe one thing that could help here is the knowledge that I counterbalance order of mention of the reference. So it's not always the first or the second mentioned character that is the target. It's half the time the first mention and half the time the second. So whatever their introduction order remains the order I mentioned them in the condition sentences. And so sometimes first, sometimes second.
That's at the beginning, right? Or is that the two sentences in between?
Both. So like in the introduction sentence, if I say frog with hat and then frog with scarf, I forgot the accessory for a minute. In the condition sentence, I keep that order, but that it could be switched.
Thanks.
Yeah.
Sarah Brown-Schmidt Vanderbilt. This was lovely. Okay, so two things that your talk made me think of. One is Meg Saylor's work on absent reference. And so coming from that perspective, in the Newland kind of paradigm, you're like, oh yeah, obviously you don't talk about the nephew anymore, but you do, right? And the absent reference literature suggests that you do. And so I wonder to what extent, given that we've established that we're talking about with this, was it a bunny or I can't remember what you're saying. It was frogs? Okay,
They're always frogs.
I saw bunnies. I don't know. Okay, we've talked about what this bunny is going to go off and do, and so in some sense you've established that bunny is the frog, whatever. That animal is the topic, and you may continue talking about it in the same way that like the absent reference literature would suggest you could. On the other side of things, there's the fairness to the other frog phenomenon, which Jesse could talk to you about as well. And so if you've already commented on the one frog, it's only fair to start commenting on the other frog. And from that perspective, is this really about a discourse representation, or is it more something more basic about, we've already talked about this one, and now we'll talk about the other one. And so I think those two explanations would make competing explanations for the phenomena, or for the pattern of data that you have, but that's what I thought about when I...
Okay, thank you. Yeah, so I think the reason that I'm thinking about this is this like pragmatic inference from the situation model is because of the effort we put into control for the linguistic prominence of the event participants. And so it was my hope that because they're mentioned the same number of times prior to that final sentence, order of mention is counterbalanced, so that helps some of those concerns. But I agree with you that all of these things matter. And also like the verb in the final sentence can change your expectations about who you think is going to be mentioned. So we might change that verb and expect more mentions to the absent referent rather than the one that's still on the scene. Like if we wanted to call, if we were going to call someone as opposed to ask someone, for instance. So I think that all of these things contribute here. And isolating one is really difficult. I don't know if that gets at.
Hi, I'm still Jessie. I have a real love-hate relationship with the visual world paradigm, right? Because it is sensitive to everything. And that seems particularly problematic when you're thinking about prediction as you are here, right? Because it could be lexical prediction, it could be phonological prediction, it could be referential prediction. And so I find it easiest to think about your study in terms of referential prediction, right? That you're actually predicting that you're going to talk about this guy. Forget about how it is that you're going to describe him. And I think if you think about it that way, right, first, it's not totally clear how to line it up with the prediction literature that you're talking about before, right? I feel like most of the evidence for example, poor prediction in L2 is coming off of a much more lexical, phonological level, right? And most of the evidence for production, maybe production is prediction, right, feels strongest when you're down to that level. Yeah. But I think it also maybe raises some interesting questions about why you would expect to get different findings than with the NREF, right? If you believe that the NREF is targeting something like the number of reference in your working model, that's very different than all the reasons why you might predict that something is going to be referred to, right, or lexically invoked in some way, even if it's not being referred to by being related to the frog. Yeah.
Yeah, I actually do think about this as referential prediction, so maybe interesting that I chose to motivate the talk this way, because this is not how I talked about the 4- and 5-year-old literature. So I think that I'm, still working on that connection to the prior literature and understanding where the similarities and differences are. I really appreciate the comment.
That was great. The follow-up that I had was, I think you may be underselling the success of the children using the measurement technique you're using. So you're using a different score for fixations to the 2 frogs,
Yeah.
right? And a different approach that used multinomial process or tree-based analyses, where you could specifically look at how much are we looking at frogs versus other things. Looking at frogs is consistent with understanding the story, and then specifically at a second node in the model, looking at the 2 different frogs. I think you might find different kinds of cognitive mechanisms explaining performance and the ability to identify. We're talking about frogs and not butterflies right now, and versus teasing apart which frog we're talking about.
Oh, okay, interesting. Thank you.
Hi, very nice talk. I'm Amanda Van Horn from the University of Delaware. I actually want to put the lens on your language impaired data,
Okay.
or at risk of language, like you
Yeah.
do a dance, right?
Yeah.
But at risk of language impairment data. I heard you say that you think it's the verb depth, knowledge of verb depth that's driving that result.
I think it's
And
one
I'm
possibility.
really curious how you operationalize the verb depth part, and then the degree to which you think the verb ask is driving then the 2-referent unambiguous condition, like where that's at chance. Like, why is that at chance then for the DLD kids?
Yeah, so I don't know a terribly lot about developmental language disorder, to confess. This is something that's new to me. Being at Purdue, I'm often around Larry Leonard, and so this is one of the things that he talks about, is that generally children with developmental language disorder have shallower verb knowledge, is what he would say. So not as strong or not as robust knowledge about verbs and their argument structure, or what kind of agents, patients, things that go with them. So why, so your second part was why is that driving the effect for the 2-referent? I think it really is because the verb in that final sentence means that someone needs to be there to
Okay.
reference. I mean, we can think of many examples where maybe ask doesn't necessarily have that constraint. So I guess here I want to bring up work that Yuile Yu did presented at BU, where we were looking at the use of the combination of situation models and verb presuppositions that they were using give and give back to. And so when you use give back to, presupposes that the prior referent that the referent had prepossession, and the 4- and 5-year-olds were sensitive to this, but they're not. So they're going to look in anticipation at the frog who had prior possession. So this is part of my thinking here about why that verb matters, is that it really changes what inference you would be making.
Thank you.
Awesome. Let's thank our speaker.